Okay, today we're going to do two short study guides on triangle congruence. And again, this is a review from Math 1, but this happened during the time of COVID, so it might not be a review. It might be brand new for some of you. So we're going to do this homework on it. We're going to do Wednesday's notes on it. We're going to do Wednesday's homework on it, and we're going to do Thursday's class notes on it. So we're getting like a whole week of review of this in case it wasn't solidified in Math 1. So let's go take a peek at what I'm talking about. So first of all, we're going to be talking about triangles and their congruence postulates. So the main idea, we don't need to know the measures of all 6 pairs of the congruence parts to know that you have two triangles that are congruent. So you don't need all 6 pairs of congruent parts. What are the 6 pairs that I'm talking about? I'm talking about this angle and this angle. That's a pair. This angle and this angle is a pair. This angle and this angle. So there's 3 pairs of angles in every, pair of triangles. And then there's also 3 sides. There's 3 pairs of sides in each triangle. And these make up the 6 parts. But you don't need all 6 pairs to know that 2 triangles are congruent. You can use the triangle congruence postulates with only some of the parts to know if things are congruent. Okay, so here we go. The side postulate says that if all of the sides, all 3 pairs of a triangle are congruent to all of the sides of another triangle, then the triangles are congruent. So if side 1 and side 1, side 2 and side 2, side 3 and side 3, if all 3 pairs are congruent, we know that the whole triangle is congruent. We don't need to know anything about the angles because all we need is 3 sides, and that is sufficient. That's called the side postulate. Which pair of triangles below shows the side postulate? So these little markings have to do with which sides are congruent. So for example, AB is congruent to ED. Also, see the little markings of 2 over here. BC and EF both have the markings of 2 sides. And then finally, DF and AC are marked 3 sides. So I could say the triangle DEF is congruent to triangle ABC by the side postulate. Why is this other 2 not an example of side? Notice that there's an angle there. There's an angle. That's definitely not the side postulate if it's talking about an angle. So which of these sets of triangles is using the side? Angle DEF and triangle ABC. Okay, so that's the side postulate. Let's look at the next one. Oh, sorry, we have to put the reason first. Okay. So the sides of triangle DEF are congruent to the sides of triangle ABC, therefore the triangles are congruent. Don't forget that reason. Okay, let's look at the next postulate. This one is the side postulate. If 2 sides and an included angle of a triangle are congruent to the corresponding 2 sides and included angle of another triangle, then the triangles are congruent. Practice visualizing this one. Let's see if you can see it. So in this one, can you see how this is let's go over here and look at this one. See how this side is congruent to this side. based on the 1 mark. And this side is congruent to this side based on the 2 marks. And this angle of 36 degrees is congruent to this angle of 36 degrees. So therefore, I can say that triangle FOX is congruent to triangle ABC by side angle side postulate. Now, why is it these pairs of triangles and not these? Well, notice this has 3 sides. So these are not using side angle side because these are using side, side, side. These are the 2 that represent our new postulate. Now, why, or the reason for that, is that 2 sides of each triangle and their included angle are congruent. Therefore, the triangles are congruent. Okay, so that's the side angle side postulate. All right. We have 2 more. Angle side angle is the next one. So this time, if we have 2 angles and an included side of a triangle that are congruent to the corresponding 2 angles and included side of another triangle, then the triangles are congruent. So let's go see which one looks like this ASA postulate. So again, I'm looking for 2 sides. 1, 2, and, oops, I'm sorry. I highlighted the wrong thing. I'm looking for angle, side, angle. So ignore the blue. Here's angle 1. Here's angle 2. And here's the included side. Sorry about the highlighting of the blue side. We don't need that side because we're looking for angle, side, angle. Here's angle 1, here's the side, here's angle 2. Here's angle 1, here's the side, here's angle 2. Notice the side is in between the 2 angles. Notice that the side is in between the 2 angles, just like the S is in between the 2 A's. For this to be an ASA, the side needs to be in between the 2 angles. That's what an included side means, in between the 2 angles. Okay, so I can say that triangle XYZ is congruent to triangle RST by angle side angle postulate. What's our reason for that one? 2 angles of each triangle and their included side, which is the in-between side, are congruent. Therefore, the triangles are congruent. Okay, so that postulate is the ASA, angle side angle. It's got 2 angles alongside of 1 included side. All right, last but not least is our AAS. Angle side says that if 2 angles and a non-included side of a triangle are congruent to the corresponding two angles and side, non-included side of another, then the triangles are congruent. So this time, this side does not need to be in between. As an FYI. Okay, so which one has an example of that? We're looking for two angles and a side. So for example, here's an angle. Here's an angle. And notice it's not the side in between those two, but this side out here. And this postulate says that we still have congruence. So we can say that triangle XYZ is congruent to triangle RST by AAS, or angle, angle, side. Reason: two angles and a non-included side are congruent. Therefore, the triangles are congruent. I keep coughing in this video, sorry. Okay, so that's our final one. Now, let's talk about, those are the four things that do work, but let's talk about the things that don't work. SSA, having two congruent sides and a congruent non-included angle, is not enough to prove that two triangles are congruent. This can also be written in reverse. SSA or ASS does not work. Does not give us congruence. And then AAA, having all congruent angles, is not enough to prove two triangles are congruent. So what do I mean by these? So for example, if a triangle has three angles that are the same, picture this little tiny triangle. Let's say it's an equilateral triangle with three equal angles, right? There's my equilateral triangle. What if I drew a big mama version of this, of an equilateral triangle with three equal angles? Are those two triangles congruent? Definitely not. Their three angles are congruent, but their side lengths are definitely different. So three angles is not enough. And the same way I could prove that two sides in an angle is not enough. So if that's what you're given in a proof, you would say there's not enough information for congruency. You cannot prove that they're congruent. Okay, let's label each pair of triangles with the postulate that would apply. Notice in the first one, there's a 5 and a 5, a 9 and a 9, 10 and a 10. This one is by side, side, side. Notice in this one, there's a side and an angle and a side. So it's our SAS. Here I have an angle, a side, and an angle. And here I have an angle and a side. Notice that for ASA, the two angles are on the outside of that middle included side. Notice on AAS, it's an angle, then the side's way out here. It is not in between. The side is not in between. Okay, now let's go practice some examples with this 2, 4 knowledge and see what our checkup is going to look like. So for questions 1 through 4, which congruence postulate theorem would be used? Notice the 8s, the 9s, the 11s. This is side, side, side. Notice the 14, the angle, the other side. This is side, angle, side. Notice the 85, the 5. So this is angle, side, angle. Notice two angles with a side outside of it. There's our AAS. Okay, let's go look down at number 5 and 6. What else would need to be congruent to say that these two triangles are congruent by AAS? So if I have that this side and one angle are congruent, I need the other angle to be congruent. I would have to know that angle C is congruent to angle F in order to be able to use AAS for this one. What else would need to be congruent to show that ABC by SAS, that these two are congruent? So if we need side, angle, side, we would need side AB congruent to side DE. And if I had that side right here, then I would be able to say by SAS. If I had this angle here, I would have enough for AAS. Let's open up this answer key here too so you can see it. All right, so for number 7, what else would need to be congruent to say this is a side, side, side? I would need this side to be congruent to this side. For this one to be able to do angle, side, angle would need to be this guy right here. Angle B congruent to angle E. For these down here, if I want to do it by AAS, I need angle, angle, and a side. So it would need to be the one that's far apart from it. So this one is reflected, so that's this guy over here. So angle B would have to be congruent to angle E. And finally, to do side angle side, side angle side would have to be this guy right here. Would also have to be congruent. AC would have to be congruent to DF. Okay, now that we've looked at the postulates and now that we have looked at the parts, get ready for the next section when we talk more about these postulates.